Second case of calculating particular integral. In the last session, we learned about how to get the particular integral if we have a exponential function. In exponential function, the shortcut method says just replace d by a and get the particular integral. Now, in the case of trigonometric function, whenever we come across, just a minute, whenever we came across this trigonometric function, the key element that you should remember, we have to replace d square by minus a square provided the function is sin ax plus b or cos ax plus b. So again, in a trigonometric function, we are considering sine and cosine only. Sine and cosine only. So this method is only for trigonometric function of sine and cosine. So whenever sine of ax plus b is there or cos of ax plus b is there, just replace d square by minus a square. And if we get a denominator as a constant number, so that will be our answer. So this is the case number one. Case number one, suppose we have pi of 1 upon d square plus 5 of sine of 2x plus 3. So we'll replace here d square by minus 4. D square by minus 4. So this d square is replaced by minus 4 and we are getting a constant number. So this is the answer. So that is the end of the part. So we got the answer there. Whenever we replace d square by minus a square and we get a constant number, we get a constant in the denominator, we have to stop there and we get the answer there. So that about case 1. But while replacing d square by minus a square, like d square by minus 4, if denominator comes to 0, the same thing that we have to do it like the exponential part, multiply by x outside the operator and differentiate the denominator. So here x is multiplied and the derivative of d square plus 4 is written as a 2d and that sign. Now this is one more important thing you should remember throughout. D is a derivative operator while 1 by d is integral operator. Now we left with only 1 by d, and whenever 1 by d is there, it's an integration of that, integration of sine of 2x plus 3. So integration of this part and we get this as answer there. So after integration. That about case 2, provided the denominator comes to 0. And the last case, case number 3, it may happen that we get a linear term in the denominator. Okay, let me come this part. Suppose the phi d is in this form, d square plus 2d plus 3, and we replace d square by minus 4. We replace d square by minus 4. So minus 4 plus 3, this become 2d minus 1. So now we have 1 upon 2d minus 1. And whenever there is a linear term in the denominator, we have to do a rationalization. So that's the case number 3. The rationalize is the important thing, that multiply by conjugate of a denominator. So multiply by 2d plus 1 in a numerator and denominator, and we get this 2d plus 1, and this will be converted as 4d square minus 4, and now it is a d square, and we can replace the d square by minus a square. So we can replace d square by minus 4. So minus 4 into 4 is minus 16 minus 1, that is minus 17. Minus 17, 2d plus 1 as it is. Now this only operator that we have to operate on this trigonometric function. What is that operator? This is actually a derivative operator. So this minus 1 by 17 as it is, 2 times derivative of sine 2x plus 3. 2 times derivative of sine of 2x plus 3. Derivative of sine is a cos of 2x plus 3 into 2. So that is into 2. Plus 3 times, plus 1 times sine of 2x plus 3. So plus 1 times sine of 2x plus 3, that's one. So this 2 into 2 is written as 4 cos 2x plus 3. So that about the 3 possible cases in trigonometric function. Remember, if you understood this slide only, if you understood this case 1, case 2 and case 3, you can solve any example of a trigonometric function, because whenever we replace d square by minus a square, either we get a constant in the denominator, or we get 0 in the denominator, or we get a linear term in the denominator. So depending on the case, we have to do the next process there. For example, constant, answer, getting 0, multiply by x, differentiate the denominator, and last linear term, rationalize. So that are the 3 important keywords you should remember there. Okay, so it become more clear now. If we start the numericals, let we start one example on this. So question number 1 is here on the screen. So step number 1, I want CF at least from you. Step 1.
Sir, d cube plus 4d
Yes,
is equal.
YC. First of all, it is a d cube plus 4d. D cube plus 4d is a 0. So what are the roots? Yes, it is written in the form of d, correct. D cube plus 4d. We written auxiliary equation only. So d is a common. D square plus 4. So d is equal to 0
Plus
plus or
minus 4.
minus 2. So tell me YC then. Tell me the complementary solution.
So c plus cx.
Okay, C1. Okay, you are
Sir,
taking.
C1 e to the power 0x
Okay.
plus
Huh?
C2
Huh?
e to the power 2x.
Okay, so my mistake. Just a minute. Correct. You are correct. C2 e raised to minus 2x. C3 e raised
Plus,
to. Okay, is it?
yes,
So the order is not important. The order is not important. Remember, this is a 0x. Just a minute, I will correct it. Otherwise, you will confuse. So this is e raised to 0x. C1 e raised to 0x plus C2 e raised to 2x plus C3 e raised to minus 2x. That is also okay. So you can write minus first and plus later on. It doesn't matter. Order is not important. So the problem, there is not a problem in YC there.
Sir, excuse me, sir. I have one doubt, sir.
Yes, yes.
Sir, it will be plus minus 2i
Plus or minus
Yes, sir.
2i. Okay, very
iota.
good.
2 item.
Okay,
Yes, sir.
good. So that is my mistake. Yes, correct. Yes, you identified that. So the roots are not correct. It is plus or minus 2 iota. So you are correct here. Plus or minus 2 iota. So YC will be C1 e raised to 0x, then
e to the power
0x.
Alpha
No need to write that.
0. So
C2
c1 cos 2
plus,
sin
is
2.
that?
Sin. Yes.
So that about YC. So getting a YC is throughout the topic, it is the same. Complementary solution, yes, it's the same. But YP is important now. Step 2, YP is equal to 1 upon phi d. Or in this case, phi d is a d cube plus 4d of sine 2x. Yes, next step, anyone? What should be done? Yes, anyone?
So replacing d
replace
by
d square by
0.
minus s.
We replace d square by
Minus 4.
minus 4. Replace d square by minus 4. So only the terms of d square we can replace. Remember, the term of d we cannot replace. We have to keep as it is. So here 1 upon this d cube can be written as a d square into d. D square into d. So if you replace d square by minus 4, it become minus 4d plus 4d. Okay. So we can say then phi of phi of uh, phi of minus 4 is coming 0. Is that when you replace it is by d square by minus 4, d square by minus 4, it is coming 0. So what should be done? What should be done? You can observe when you replace d square by minus 4, so it becomes minus 4d plus 4d. That is coming as a 0. So as it is coming 0, we should multiply by x. We should multiply by x and differentiate the denominator. And what's the derivative? It's a 3d square plus 4 sine 2x. Are you getting? Because when you replace d square by minus 4, then function becomes a 0, denominator becomes a 0. Because of that, multiplied by x to the LHS and differentiated the denominator. Can we replace now d square by minus 4? Yes, because it's
So,
not coming.
sir,
Yes.
So what you have written d square, replace d square by minus 4, and beneath it you have written then
Then
5 of
functional value,
minus 4 equal to 0.
then functional value of denominator coming 0.
Sir, 5 of
Okay,
minus
I
4
will write it.
cannot be
I will
0, no,
write
sir.
it properly.
5 of d is 0 only, no, sir.
I will write it properly here. Then minus 4d plus 4d is coming as a 0. Okay, that way. Okay, means we are not replacing d by minus 4 there. Actually, we are replacing d square by minus 4. Then denominator become, this is minus 4d plus 4d, that's a 0. Is it okay?
Yes, sir. I was just correcting your
Yes,
written.
written part. Correct, correct. I got it. So that denominator is coming 0. Now we replace d square by minus 4. And now we have the answer here, because the denominator, this minus 12 plus 4, minus 12 plus 4, is it a minus 8? And that about yp. Remember, in final examination, don't forget to write yc plus yp together. Okay, again examiner will deduct the marks if you not write the complete solution yc plus yp there. Okay, so on the first part here, here is yc and here is yp. So just you have to add it together and that will be your final answer. Any doubt? If you have the doubt, yes, you can ask.
Sir,
Yes.
sir, the last step, sir. We are following case number 1 or case number 2, sir.
This is case 1 now, because constant term in the denominator. We got a constant. Here we get case 2 actually first. When we replace d square by minus 4, the denominator is coming 0, so multiplied by x. And difference set phi dash d is written. Here, when we replace d square by minus 4, we get a constant in denominator. That is case 1.
Okay, sir.
Okay, we replace d square by minus a square in trigonometry. So once you finish, tell me. We'll move to the one more example here.
Sir,
Yes.
sir, how we came to know that what should be replaced?
So here these are the
Before.
shortcut methods we are learning. So at the end, means after 4 methods, actually replacement is only for three to four methods there. So later on you have to remember that for exponential you have to replace d by a. For trigonometry you should replace d square by minus a square. For hyperbolic you should replace d square by plus a square. That's one you have to remember only. Okay, hardly there are four things. Otherwise, the regular methods are too lengthy and they're never used. Okay, so at the end we sum up all the replacements there. Then you can definitely remember it.
Yeah, okay, sir.
So are you completed this?
Yes, sir.
Okay, so one more question. Okay, someone is asking now how C2 cos 2x and C3 sin 2x is there. Asif, you are absent. You should learn the method of CF first. Whenever there is a complex pair, if alpha plus or minus I beta is a root, okay, alpha plus or minus I beta is a root, then CF is a e raised to alpha x, C1 cos beta x plus C2 sin beta x. So you go through that recorded video of a CF, then you'll get it. Question number 2 is here on the screen. Okay, step 1, YC. In a solution, step number 1 is a YC. To get YC, we equate auxiliary equation to the 0. So it's a d raised to 4 plus 6d square plus 8 equal to 0. Now you should tell me the roots. How to get the roots now?
D square plus 4 at D square plus 2.
Very good. So actually this is a quadratic in d square. So it is directly, these are the factors. What are the roots then? D is equal to
Plus minus 2 iota plus minus root 2 iota.
plus or minus 2 iota and plus or minus root 2 iota. Okay, so these are the roots. So again, if you compare with alpha plus or minus I beta, if you compare this with alpha plus or minus I beta, it says e raised to alpha x c1 cos beta x plus c2 sin beta x. That is the root. So therefore yc will be, yes, anyone? E raised to 0x, no need to write it. Okay, because e raised to alpha is a 0 there. C1 cos beta x, so C1 cos 2x,
Plus C2 sin 2x.
correct.
Then plus C3
Hmm,
cos root 2x.
correct. And lastly,
Plus C4 sin root.
root 2x. Very good. So it's lengthy solution, but yes, it is very simple. Just compare with alpha plus or minus I beta and write entire CF there. This is the complementary solution or complementary function of the differential equation phi d of y equal to fx. But the step 2 now, in step 2, yp is equal to 1 upon phi d. So phi d is, in this case, it is d4 plus 6d square plus 8. What about 2 sine square x? Because we have the formula only for sine ax plus b. So we should convert that power of the trigonometry to the,
1 minus cos 2x.
very good, 1 minus cos 2x is 2 sine square x. Good. So this is conversion of square into the addition or multiplication. Now we have to apply this operator on both. How to operate this 1 upon d square on a constant one? Yes, anyone?
D0.
Yes, replace d by 0, because we already run for constant. For constant, we can write it, 1 can be written as e raised to 0x. Okay, minus 1 upon d4 plus 6d square plus 8 of cos 2x. So in the first case, yes, we replace d by 0, so it is coming 1 upon 8. Okay, I will write it here, just a minute. 1 by 8 only, e raised to 0x is 1, so we'll not go in that. What about second part? We should replace d square by,
Minus 4.
so it is minus 4 into minus 4, it is a 16, is it? Minus 4 into minus 4 is a 16. This is a minus 24 plus 8. What happens?
Becoming 0, sir.
Becoming 0. So what should be done?
X by differential.
Yes, we should multiply by x and then differentiate the denominator. The 4d cube plus 12d of cos 2x. So this 1 by 8 still continue as it is till end, minus x as it is. Now we'll replace d square by minus 4. So if you replace d square by minus 4, yes, anyone? What will be the term if you replace d square by minus 4?
Minus 16d.
Correct, minus 16d plus 12d. There is no replacement for d, remember, whenever you do a trigonometry. Just we replace d square, d4, only that terms, even power of the terms. So this can be simplified as 1 by 8 minus 16 plus 12 is a minus 4d. So plus x upon 4d of cos 2x. Now it is 1 upon d. This 1 upon d.
Integral.
It is integral of cos 2x now. 1 by d of cos 2x means integral of cos 2x. So what will be the last step or the answer here? So I will write the answer on the top now. We don't have the space, so I will write it here. Therefore, yp will become that 1 by 8 as it is, 1 by 8 as it is, x by 4 as it is, x upon 4 as it is. Now 1 upon d of cos 2x. What is integration of cos 2x?
Sine 2x by
Sine 2x upon 2. That's one. And just we have to write down the answer then. Thus yp will be that is 1 by 8 plus x by 8 sine 2x. And that's the end of the
Sir,
question.
here the integral operator is operating upon the variable x, right?
Correct, correct. So
So why we
actually,
didn't took x inside?
no, x is outside the operator there. This is x when you, because this x comes outside the operator. That's a part of the shortcut method. Whenever we have to find out yp and the denominator comes to 0, when this denominator comes to 0, we multiply x outside the operator. So this x is already outside the operator. You cannot operate this operator on x. So whatever the remaining operator, you have to operate only on cos 2x. So because of that, I am writing here. Otherwise, if you write it here, you make a mistake then. If you write multiplied by x this side of the operator, that indicates you have to operate that operator, because when you write d dx of x, it is answer is 1. The answer is 1. And if you write x d dx of 1, so the answer will be 0 then. So writing x on the correct side is important. Whenever we multiply by x, multiply x to the outside the operator, not inside the operator. So if you multiply this side, you made a mistake then. So once you complete, tell me. And if you have the doubts, yes, you can ask. Okay, Sanchit is asking how 1 by 8. Because here constant term was there. So to get a constant, we have e raised to 0x. We replace d by 0. Replace d by 0, you will get 0 plus 0 plus 8. No? So 1 by 8. Are you getting? Are you asking that 1 by 8 or this other 1 by 8? Sanchit.
सर
Hmm.
सर वो a to the power 0x कैसे लिख दिया सर
1 can be written as e raised to 0x ना कांस्टेंट का pi लेते वक्त हमने ऑलरेडी लास्ट मेथड में सीखा है exponential function can be in three forms. Exponential function can be in three form, either e raised to kx form or x raised to k form or constant form. So whenever e raised to kx is there, we replace d by k. Whenever x raised to k is there, we replace d by log k. And when k is there, k can be written as k into e raised to 0x. Is that? And we replace d by 0. So here only 1 is there, na? So 1 can be written as e raised to 0x. E raised to 0x is only 1, na? Is it clear?
ओके सर
Okay. So just remember, whenever you come
यस
across a
यस
constant term, you have to replace d by 0. No need to write e raised to 0x there actually. You can write it 1 also. You can write this as 1 also. There is not a problem. You write it 1 only. But for constant, we replace d by 0. You can say d by 0. And here we replace d square by minus 4. D square by minus 4 there.
सर d में तो ट्रिग्नोमेट्रिक फंक्शन के अंदर जो वैल्यू है वो जाती है ना
Pardon? D में?
तो इधर तो ट्रिग्नोमेट्रिक फंक्शन d में तो सर जैसे cos 2x है तो 2x का 2 जाएगा अंदर तो सर इधर तो cos इधर तो ना cos है ना sin है सर तो 0 कैसे डाल दिए
No, this side, na? And
यस सर
there are two terms. One is 1 minus cos 2x is there. So what we done? 1 upon d square plus 6d square plus 8, we are operated on 1, then minus, and this operator we operated on cos 2x. Now to operate it on 1, it is considered as e raised to 0x, and we replace d by 0 there, and we got this term. Is it? And for trigonometry, we replace d square by minus a square. Yes, correct. At last you have to write out as if yc plus yp you have to write it. Don't forget to write yc plus yp in each and every numerical there. Number of solved examples I given in PPT, and that time I written how to write the complete solution. So next question are the solved example only that I will show you quickly, and then we'll stop. Okay. So can I move to the next question here?
Yes, sir.
Okay. So question number 3. So see the way how you write in the exam. You should write this way in the examination. This is the numerical you are given. Step 1, we should calculate yc. To get a yc, d square plus 2d plus 1 equal to 0. That is equated to 0. That is auxiliary equation. And we get minus 1. Minus 1 is a root, which is a repeated root. So for repeated root, we have the yc in this fashion. That is c1 plus c2x e raised to minus x. c1 plus c2x e raised to minus x is there. Okay, here is minus sign. Next, getting yp, which is 1 upon phi d of fx. In this case, phi d is a d square plus 2d plus 1 of a 4 sine 2x. The method says we should replace d square by minus 4 because it is sine ax plus b. We compare it with sine ax plus b. So we replace d square by minus a square, in this case d square by minus 4. So when we replace d square by minus 4 plus 2d plus 1, we get a linear term in the denominator. This is the case number 3. So what should be done in such a case? Whenever the linear term is there, multiply by a conjugate. It is a rationalize. Okay, rationalize. So multiplied by conjugate of 2d minus 3 in both numerator and denominator, so that the denominator is converted as a 4d square minus 9. And now we can replace d square by minus 4. Replace d square by minus 4. 4 into minus 4 minus 9. So it is a minus 25. So that about this 4 is also taken out. So minus 4 upon 25. 2d plus 3 of sine 2x is written. 2d plus 3. So minus 4 upon 25 as it is. 2d of sine 2x plus 3 of sine 2x. What is the d? D is a derivative operator. D is a d by dx operator. So d of sine 2x means the derivative of sine 2x. So derivative of sine 2x is a cos 2x into 2. So that's written here. And 3 sine 2x as it is. And that becomes yp. So yc plus yp is the complete solution there. Yc plus yp is a complete solution there. Okay, you can go through this solved example because this is already in the PPT. Only if you have the doubt, you can ask. Don't write anything here because you can note down it later on from the PPT. Any doubt here in this question 3? Okay, so last question I will show you here. Question number 4. Solve d square plus 1 of y is equal to sin x into sin 2x. What is the difference? The difference is RHS is not only sin ax plus b, it is multiplication. So obviously what should be done? We have to convert that multiplication to the addition. So defactorization formula, that only the extra part that we have to do. YC is simple. Getting d square plus 1 equal to 0. We have plus or minus as a root. So c1 cos x plus c2 sin x is a yc there. Step 2 is yp, which is 1 upon phi d of fx. So in this case, 2 sin a sin b is written as a cos of a minus b minus cos of a plus b. Okay. This is a 1 by 2 times cos of a minus b minus cos of a plus b. That's the formula used. So converted multiplication to the addition, and we get this part. Now whenever we have to operate, this 1 by 2 is a constant taken outside the operator, this operator, And this is 1 upon d square plus 1 of cos x and 1 upon d square plus 1 of cos 3x. So this we replace. What is the replacement done for this first part? Yes, anyone? What is the replacement done here for cos x? D square by
minus
minus 1. Okay, and here d square by minus 9. So for first term, we replace d square by minus 1, while the second term we replace d square by minus 9. And but here, when we replace d square by minus 1, this denominator comes to 0. So multiplied by x, differentiate the denominator. That's it done in the first term. Second term, we replace d square by minus 9 directly because it is not coming 0. And 1 upon d of cos x means integration of cos x is the sin x. And that becomes yc plus yp as a final answer there. So that about last question on trigonometric function.